Okay, so day 2. How are we feeling? Were you guys able to get the textbooks? I see some of them out there. That's cool. I'm not really assuming that you've done the reading just because, not to be like, you didn't do the reading, but because you didn't have very much time to do it. But remember, I do want you to kind of skim the chapters, even if you're not reading it hardcore, at least so you've seen all the material beforehand, right? And so, can't remember for next day, and I didn't write it down. I'll post it on Moodle. It'll be in the next week's section, what you're supposed to read for next week. And then you can just get caught up over the weekend. That's what's weird about the Monday, Wednesday classes. There's so much time until Monday, until it's Sunday night, and then it's feeling like that wasn't very much time, right? Okay, so we've got class today, and then lab on Friday, right? Remember, you can come to either of the lab times. There's an 8 a.m. lab and a 9 a.m. lab. Right, they're just for an hour, bless you. So you can come to either. They're in different rooms, so you'll have to check. I'll post that as well. But I'll have to make a note. Lab rooms. You can look it up on ClassFinder, but anyways, I'll post it. So you can come to either of the labs or both of them if you want, right? And remember, it's just going to be like a help session. Of course, this is our first lab, so we'll do kind of like, well, Excel might be familiar to most of you. Sort of, or at least have worked in it at some point, opened it. One thing that I will say is that you can definitely bring your laptop to the lab. So we will be in a computer lab, of course. So there will be computers there. But if you prefer to work on your laptop, because then you can just continue working on it later or whatever, it's just more familiar, right? Then absolutely bring your laptop, and then you can just ignore the desktop. Right, so that's easier. So you are welcome to come to either of the labs. Oh, I do know where it is. It's on my phone. From 8 to 8:50, I'll be in C286. And from 9 to 9:50, I'll be in C278. We just hang out in this building, huh? I'll put in brackets or both if you want double time. Or if you've already had a look at the lab, looks manageable, then you're welcome to skip lab. See if I care. Well, it'll be lonely if no one shows up. Okay, another thing that I forgot to mention last day was you have a lab, a Stat 121 lab Moodle page. I'm gonna hide those, so don't be alarmed when they disappear, because I'm just gonna have everything on the main page. So I'll have the lab stuff and the lecture stuff all on the same page. Otherwise, I'm managing all these pages and putting the same stuff up 3 times, for example. So, or at least 2 times. So I will be hiding the lab Moodle pages. So don't be alarmed when they disappear. You're still in a lab. Don't worry. Yeah. Okay. I sent out an announcement, a test run. What's the easiest way? Who got the announcement that I sent out last night? Only a few of you. Maybe check your spam folder, your junk drive, or whatever you want to call it. Or just make sure that your personal email is linked to your Moodle email, right? And so a test message was sent out last night via Moodle. Make sure you got it. Okay. So I guess it was a message. It would arrive in the form of an email. Okay. Hiding the Moodle pages, bring the laptop, the announcement. Let's do a little bit of review. So I'll always do review. Usually my Wednesday review is a little bit shorter than the Monday review, just because by the time Monday rolls around, there's been so much time, right? But it was our first class. So just as a quick overview, right, we talked about variables. There was a lot of terminology that we covered, right? We talked about variables, how they're either numerical or categorical, right? And then we went a little bit deeper. If it's numerical, it can either be continuous or discrete. And if it's categorical, it can be ordinal or nominal, right? And so we talked about variables. I'll make the tree again. So a variable is either numerical or categorical. And from numerical, it can either be continuous or discrete, right? Continuous meaning all these measurements. So if it's numerical, right, it's a measurement, a number, right? And so if it's continuous, we've got this measurement on this continuous scale, right? Meaning that the only reason that we had to stop at 2 decimal places, for example, is because our tool can only go to 2 decimal places, right? That doesn't mean that we can't go beyond that. Or discrete, things like age, for example, right? I would say I'm hitting this, I think 33 we decided on. I don't know, I don't remember. So I'm 33 years old, right? You're however old you are, right? And so we go in these discrete numbers after the age of 2, right? Probably before 2, you go in months or whatever, but those would still be discrete, right? You don't have it down to the millisecond. Okay? Categorical variables, right, are either nominal. So categorical variables are things that we've collected information that can be put into categories, or should be put into categories rather than a number. And so a nominal variable would be a categorical variable with no order, right? And so nominal, no order. So there's no natural ordering to these things. So we talked about hair color, right? That would be a category, right? And then, but there's no natural ordering, right? Whereas if you have natural ordering, then you have an ordinal variable, meaning, so things like income brackets, right? Those are categories, right? And there's this natural ordering, right? What year are you in? First year, second year, third year, fourth year? Those are categories, right? And there's natural ordering, right? So we talked about variables and just kind of getting comfortable with the lingo. And so later on today, we'll start talking about categorical variables. How do we look at them? How do we summarize them? And then later we'll get into numerical variables, because like I said, numerical variables are a lot more powerful, right? So there's a lot more information in numerical variables. Things like averages are just kind of huge in stats. Right? And so, and you can only take the average of a numerical variable. Right? All right. We talked about how do we select a sample, and we'll talk more about it today, right? But we said, well, the whole idea is if we have a research question, then we have identified some target population, right? So some population that we want to know something about. So what we do is we take a sample from that population, and we have to make sure that it's representative of the population, right? So there's this, there's always this exchange between the population and the sample. And so to make sure that our sample is representative, we have to have a random sample, right? And so there's lots of different ways that we can collect a random sample, and we'll talk about those today. But randomly selecting a sample will ensure the sample is representative, representative of the target population. And then as the course goes on, right, over the next few days, I'll drop the target population. It's just kind of understood. If I say the population, of course I mean the population of interest, right? And so it's just kind of understood. And so we talked a little bit about bias, right? Bias is the opposite of a randomly selected sample. And so it's kind of the bad sampling side, right? If there's bias in our sample, then our sample won't be representative of our population. And so, got a page break here, so we want to avoid or ideally eliminate bias in our sample, right? So we want to avoid, I'll do /eliminate. Very hard to eliminate it, right? But we want to do our best to avoid bias. So we want to avoid /eliminate bias in our sample. Since it won't be representative of the population. Since a bias sample, I'll say, since a bias sample won't be representative of the population. Do a little squiggly to indicate the end of our review. Any questions from last day before we get into this new day? I'll never tell. Okay, so let's talk a little bit more about bias then. Where would it come from? I think we have a pretty good understanding of where bias might come from, right? Bias would be if I am influencing the outcome of a study, right? Whether it be intentional or not, right? And so bias can come from many sources, and it's like this unwinnable fight, right? But you do your best to avoid bias at all costs. So bias can come from many sources, right? Most commonly, from the first one, I would say would be non-response. And so if you're doing a survey, right, so a lot of information comes from surveys and just kind of reaching out and trying to collect information and having no luck. So I always do the surveys. You know, when they call you at a really bad time, it's always at a really bad time. And maybe because you just don't want to do it. But anyway, so I always do those surveys because I feel really bad. But that's another kind of bias, right? Because I will always do the survey. And so someone who won't do the survey, right, we're not going to get information from them. So even then, there's bias in there. Because I've been the one on the other line or the other end of the rope, sitting there waiting for completions. So we had a survey house downstairs and then we did the analysis. And so you're just kind of checking, hitting refresh. How many survey completions have we done? Oh, 13. That is not enough. Gotta wait a few more days. Okay, got a few more. It's hard. So non-response is, of course, if you've tried to get information from someone and you didn't get it, right? Whether they didn't pick up your call, right? Or they just declined to do the survey, or you sent them something in the mail and they just didn't mail it back, right? Any sort of non-response is, well, non-response bias, right? And so non-response is when I'm going to say a person, should probably say a subject, right? But usually it's people that are deciding to not respond, right? And so when a person selected to complete a survey doesn't respond, right? We have non-response bias. We have non-response bias. Right. So that's really common. It's really hard to get information, especially in a survey form, right? The other one is usually budget related, right? And so we end up taking convenience samples. And so you don't take a random sample, you just go and you collect as many survey completions as you possibly can, right? And then you take those and you analyze them, right? But those would be, so convenience samples are usually budget related, right? But they do introduce more bias. And so a convenience, oops, I did not. Convenience samples, right? Sampling only those that are conveniently available to you, right? If you're trying to draw conclusions about, let's say 25-year-olds in the Okanagan, but you only sample here at the college because that's where you are and you don't want to go anywhere else, right? That's not all 25-year-olds in the Okanagan. It's a lot, right? But we've got more up at UBCO, and then there's more out in the universe, right? So even though we're talking about just in the Okanagan or even just in Kelowna, right? Just sampling here at the college would be a convenience sample, and that's not representative of the whole population of 25-year-olds in Kelowna even, right? So convenience samples is when so sampling only those that are conveniently available introduces bias to our sample. Introduces bias, I guess I should say in our sample. Bias meets sample, sample meet bias. No, introduces bias. Now I can't decide. What do you guys think? In our sample or to our sample is a little bit funnier. Anyways. Okay. There's lots of other ways that we could introduce bias, but those are the main ones that we really need to keep an eye out for, right? And so the whole point of this course, I would say, is when you go out and you continue in your field, wherever that may be, right, you're going to start being more critical of studies that you're reading, right? And so when you see someone's collected a sample, right, you want to know, well, was it randomly selected? How was it randomly selected? And we'll talk about a couple of different common options, and really keep an eye out for, you know, was there non-response bias? Could this be a convenience sample, right? And then from there, right, how was the sample selected? You'll be able to determine if the results are reliable or not, right? Because if the sample isn't good, the results are definitely no good, right? So we need a good sample in order to have good results, or reliable results, not necessarily good. It's not always what you think it's going to be. And so we're going to talk a little bit more about just how we collect data. So kind of the same way as the variables were set up, right? There's only two ways that we can collect data. We can do observational studies, or we can do experiments. And so however we collect data, right, we kind of know what experiments are, right? Got a scientist and, you know, they're giving out pills or whatever, right? That would be an experiment where you're controlling a lot of the factors, right? And you're controlling the treatment, you're controlling all these other variables, right? So that would be an experiment. Observational studies is everything but an experiment, right? And so anytime that you're pulling data from StatsCan, for example, or Statistics Canada, I guess, right? So you can pull data from StatsCan, you can pull data from medical records, you can pull data from the college registrar, you can go out and you collect data through a survey, right? So all those would be observational studies, right? But for me, I think it's easier to just say, well, if it's not an experiment, it's an observational study, right? And so there are two ways. Oops. There are two ways we can collect data. The first one being, oops, an observational study. And the second one being an experiment. Let me just see if I should talk about, got a ways to go. Okay, So first we'll talk about observational studies, and then we'll talk about experiments. But maybe I should make a note about what I said. So it's easy to identify an experiment, right? Because, you know, it's usually done by some researcher and they're controlling for all the factors, right? So an experiment is when a researcher is able to control all or most, right? Ideally all, right? But usually it's just most variables in the study. Any other study is an observational study. Right? Any other study is considered observational. So, observational studies, right? There's actually, it can be divided into two more groups. It's not going to be important, but it is terminology that we have to talk about. So you can do a prospective study. So that's when, you know, you've got a research idea and you collect a group of people and then you start collecting data, right? So things like, okay, well, a before and after, let's say running group, right? You collect people to participate in your running group and you record their times or whatever, and then, or speeds, I don't know. And then they do your program, and then afterwards you collect the same information and you want to see how they improved, presumably, right? And so you've collected this group and then you're following them into the future, right? That would be considered a prospective study, right? A retrospective study is just when you've gone back and you've just collected information, right? So information that already exists, you're collecting it, but either way, it's an observational study. So, oh, I guess I've got a page break here. In observational studies, we simply observe information. Either prospectively right? I'll put in brackets, start collecting information now and into the future, right? Prospects, future. Right? So start collecting information now. And continue into the future. Or retrospectively. Oh. So the program I use, if I hold my pen too long, it turns my letters into symbols. I guess my R turned into a circle. And I do find it funny when the symbol is really far off of what I meant to write, like an R turning into a circle, I don't know. Or retrospectively, by collecting information that already exists. So as you can probably tell, right, having a sample that's representative of our population is going to be kind of the foundation of everything that we do, right? We have to have a sample that's representative, right? And so we put a lot of effort into trying to achieve that. And so since any conclusions we draw, right, assume that we have a representative sample, right? We put a lot of effort into collecting our sample. So since any conclusions we draw assume our sample is representative, we put a lot of effort into making sure our sample is representative, right? Or making sure we put a lot of effort into making sure our sample is randomly selected. Our sample is randomly selected. I'll put in brackets, right? Because if it's randomly selected, we can assume that it's representative of the population, right? There's no reason for it not to be. So thus, representative of our population. We're only going to talk about, I think, 1, 2, 3, 4 different types of random sampling. There's a lot more. People spend a lot of time trying to figure out how to make things truly random, right? And so we'll talk about kind of the main players, right? And so, but there's lots of different sampling strategies, right? And so the first one, the 4 most common random sampling strategies are, the first one is a simple random sample. No. A simple random sample, which is abbreviated SRS. Right. And so later on, when we're working on problems, they'll usually state, oh, you collected an SRS of manatees, for example, right? Because I love manatees. So you collected an SRS. That means you collected a simple random sample, which in turn means that you can assume that this sample is representative of the population, right? So in stats, there's going to be a lot of that where, okay, well, you told me it was random, so that means that I can assume that this sample is representative of the population. Great, moving on, right? And so, so the SRS is going to pop up, start kind of popping up later on, but for now, we're just going to talk about what it is. It is exactly what the name is, so it's kind of hard to, it's just a plain old random sample, okay? So, how do I, it's a simple random sample. It's a basic random sample. Simple is better than basic, isn't it? Can't get around it. Right, but this is where you take your population, right, and you just randomly select from it. And there's lots of fun ways that you can randomly select, right? It assumes that you know the whole population, right? You have basically a list of the whole population, right? Then you could use a random number generator from random.org. Is the best random number generator, but there's a random number generator in Excel. It's not truly random. No computer can generate a truly random sample. Good enough, right? But not truly random, because it's still been programmed, and so it does follow some sort of algorithm, making it not random, right? But random enough. So what you could do, kind of the easiest, the laziest thing to do. So the way I do it is I just have a list of the population or the people that I want to choose from, right? Or the manatees maybe that I want to choose from. And then I make a list of random numbers in the next column. And then I sort them, and I take the first 10, for example, right? I sort them by the number that they were assigned, and then I pull the first 10 or every other one, or I don't know, something weird like that, right? But so now they're sorted by that random number, and then we can pull a sample from there, right? And so this is where we assign. You could also do things like flipping a coin. Heads, you're in the sample, tails, you're out of the sample, right? We had a small population like this room, for example, right? Then you could flip a coin for everyone. You're in, you're out, you're in, you're out. Right? Flipping a coin is random. So there's lots of different ways, but I'll just say assign a random number to each individual in the sample, sort them by that number, and then pick the, I don't know, top 10, top 5, top 15, whatever you want. Sort them by that number and select the first 30, for example. Could just as well select the last 30, doesn't matter, the middle 30, every 30th observation, something like that, right? And select the first 30 observations, right? Oh, should we get a little sneaky here? Instead of 30, we're jumping ahead a little bit. Lowercase n. Don't worry, it's going to be very familiar by the end of this course, because n is your sample size. Look at us getting wild here. Feels good. Feels like we're ahead of the game already, introducing and wow. So that would be a simple random sample. You've just got your whole population to choose from, and you just select them randomly, right? We could do something like stratified sampling. So stratified sampling or if we want to call it stratified random sampling and abbreviate it SRS. No, that doesn't work. It's already taken, right? So stratified sampling is, so a strata, right, is essentially a group, right? Usually a group of similar things or similar individuals, or for example, if we're sampling here in Kelowna, we would probably divide Kelowna into strata by region, right? So Glenmore, Mission, downtown, Rutland, whatever the other side is, Glenmore, Rutland, I don't know, UBCO. Right, and so you've divided your population into strata, right, groups. So divide the population into strata, right? And so these would be groups. Usually they're naturally occurring groups, right? And so region where you live in, right, that would be a naturally occurring group. Even gender, right, that would be male, female strata, right? And so you've got these, so divide the population into strata, right, which are just groups. And then take a random sample in each of those groups, right, or in each of those strata. Then take an SRS, right, a simple random sample, because now you've chiseled it down to little mini populations, right? So then take an SRS in each strata. So it's a little bit more sophisticated, right? And it just helps ensure that you're targeting each of the regions, right, in Kelowna. Right. Oops. Next up, we have cluster sampling, which is very similar, just kind of higher level. So cluster sampling we use cluster because we can't call it strata. See the name game here? We had to make up all these names, but clusters are just groups, right? Groups are strata, right? So again, we divide our population into these groups, right, or clusters, and then we randomly select which clusters we're going to take from, and then we take everyone in those clusters, right? So we don't randomly select in there, right? So instead of taking random samples in each of the groups, now we're taking a random sample of the groups and collecting information from everyone in there. So it's a little bit different. But this is when we randomly, oops. Randomly select clusters. I'll put in brackets groups. And what? There must have been a Notability update over the break, because now it is so finicky, or maybe I'm just a lazy writer now. A lazier writer. So randomly select clusters or groups and sample all individuals in those clusters. So stratified sampling and cluster sampling, very similar, right? It just depends on what the emphasis of your study is. Right? Yeah, so for the stratified sampling, you are taking a random sample from every group that you've identified. Cluster sampling, you take a random sample of the groups, but then collect information from everyone in those groups. Yeah.
Would it not be very natural? Would it not be very representative if they were naturally?
So the idea is if we randomly select clusters, then that's supposed to be eliminated. I would prefer stratified sampling over cluster sampling for that reason, right? Because then at least we're seeing things from each of the potential clusters, right? So, or we can kick it up a notch and do multi-stage sampling, which is a combination of the two, right? So now we're randomly selecting clusters and randomly sampling within those. It does kind of assume that you have a lot of clusters to choose from, right? But multi-stage sampling, that's kind of where our train stops on this sampling train. So multi-stage sampling is where we randomly select clusters then take random samples, of those clusters. In terms of what I want you to know from this, because I know this is a lot of memorization and just kind of a lot of stuff, right? If I give you and I tell you how a sample was selected, right, then can you tell me which one of these that is, right? So I don't want you to memorize the definitions or anything like that. I just want you to be able to read a blurb and say, oh, that sounds like multi-stage sampling, or that sounds like cluster sampling, for example, right? So as long as you've got the key ideas down, then that's good. Right? It's hard, but then I'm happy. Okay. Any questions about those? So the textbook does go through and it talks about tons of other sampling. Where was it? Oh yeah, judgment sampling, purposive sampling, quota sampling, referral / snowball sampling, systematic random sample, voluntary response sample, blah, 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 blah. We're not going to talk about those. There are so many other sampling techniques, right? They're in the textbook just so you can have a look at them, right? But these are the ones that I will care about, okay? So I'll just say, see the textbook. For a few other sampling techniques. But I'm not out to get you guys. In fact, I want you to do really well in this course. And so when I do stuff like that, hey, it's in the textbook. That's so that no one can get after me for not covering it. I read it to you, sort of. But it's not something that I care about, right? So I'm kind of thinning the herd that way. So everything that I write here, that's important. Everything else, that's just gravy. Okay? So don't worry, I'm not trying to have a gotcha moment on the test or anything. Okay? So, so those would be for observational studies, right, where we're trying to just collect information, we're observing it, right? So experiments on the other end of the spectrum, right, where we're trying to control everything, and we do introduce randomization in experiments as well. And experiments are unique in the sense that they're the only way that we can establish a causal relationship. So this causes a change in this, right? If we're observing things, we can say, oh, that's weird. This change, a change in this variable, is associated with a change in this variable. There's no way from an observational study that we could say, oh, well, a rise in temperature outside, right, causes an increase in ice cream sales, for example, right? We understand that to be a relationship, right? And it's a reasonable relationship, right? But we're just observing things, right? So we cannot say that it causes an increase in ice cream sales, for example, right? Oh, I wonder if I have it. I was going to show you guys later, but it's really pretty cool. So my coworker Sean showed me this site yesterday, and it's hidden from you, but I'll show it to you because I thought it was pretty cool. Where did I put it? So there's a website called Spurious Correlations. Okay. And so someone, presumably Tyler Vidgen, decided to compile this list of spurious correlations. Hey, it's not there. And I thought this one was, they're all pretty morbid. So they're all about, you know, one of them is usually pretty morbid, and then the other one is just kind of random. So the correlation, right, the relationship between the number of people who drowned by falling into a pool and the number of films that Nicolas Cage appeared in, is actually pretty tight over the years. Very weird, but pretty interesting, right? Can we say that Nicolas Cage is affecting the number of people who are drowning in a pool? No, right? Definitely not. He is not the cause. We all understand that, right? But it's easy to get caught up and say, well, this causes a change in this, right? This is an observational study. They've just observed over time, right? So per capita cheese consumption correlates with the number of people who died by becoming detangled in their bed sheets. Like I said, they're all pretty morbid. Slightly less, but also really tight correlation. Divorce rates in Maine correlates with per capita consumption of margarine. Who knew, right? So anyways, the list goes on. Always morbid. I don't know. So anyways, pretty crazy, right? But it just emphasizes that we cannot say from an observational study that this causes a change in this, right? Things, silly things like this, yeah, we understand that. right? But if we've collected the data, then it's easy to fall into that trap of, well, this causes a change in this. But if you're ever saying that, then you need to think about this. Does it actually make sense, right? So experiments, though, are unique because that's the only way that we can establish a causal relationship. So experiments, so moving on from observational studies to experiments, experiments are the only way we can establish a causal relationship. Okay. So experiments are when the researcher has control over potentially all the factors that concern an outcome, right? So an experiment is when the researcher has control over all or most factors that might influence an outcome. That might influence an outcome. Of course, if they're controlling things, then they're going to try to make things as random as they can, right? Because then they can be more comfortable with their results, have more reliable results. And so researchers will randomly assign treatments. Will randomly assign treatments. I'll put the S in brackets, right? There could be more than one treatment, right? And they'll use replication, right? So I like to use the example of so you want to know, how do you grow the best tomato, right? And so you're going to control for a lot of things, right? Things that we know and understand would affect the tomato, right? The final product. So things like sunlight, water, soil, right? Temperature of the room, right? Things like that. You would control for all those things, but also you don't just want to have one tomato plant and see what happens, right? You want to have your idea, what you think is going to produce your ideal tomato, and then you want to change it up a little bit, right? And have a control tomato plant that you think would be kind of your baseline, right? And then you want to have a bunch of other control tomato plants and a bunch of other treatment tomato plants, right? And maybe mix up the treatment a little bit, right? A little bit more sun for these guys, a little bit more nutrients in the soil for these guys, right? And so you randomly assign all these things, and that whole field sort of pun intended, is called experimental design. And it's a huge field because, as you can tell, it gets pretty complicated, right? When you're trying to assign these treatments and you're trying to make it random and make sure that you have enough observations from each group, right? And so when we have these replications, so we try to do the same thing over and over again, even in the same study, right? That will give us more reliable results, right? Because being able to say that, well, one tomato plant grew way bigger than this baseline tomato plant, that's not very powerful or reliable, right? But being able to say that, well, all of these 50 tomato plants grew way bigger than all of these 50 baseline tomato plants, right? For example. So you want to have replication to kind of boost your study. Okay, so researchers will randomly assign treatments and use replication to ensure reliable results. So you can take it one step further and say, well, I'm not just going to randomly assign whether you're in the treatment group or whether you're in the control group. Now thinking about a pharmaceutical study, for example, right? So a lot of the time, right, we've got a treatment group and a control group, but maybe there are other factors, naturally occurring factors that might affect the outcome. Right, so if age might be an issue, right, if you kind of know that age could be an issue, then you would want to kind of have a younger block and an older block, right, and then randomly assign the treatment and control in those blocks, right? Sounds familiar, kind of sounds like a sort of reverse stratified sampling, sort of, in a way, right? It's all random. So, right, so if you've got these naturally occurring things, blocks, right, can be more than 2 blocks, then you'd want to implicate, it's not the word I'm looking for, implement, words matter, then you'd want to implement blocking, implicate. So implement. So blocking gives the researcher more control by clustering, right? Blocking, clustering on naturally occurring factors that might affect the outcome. So by clustering, right, to kind of bring in that other terminology, / blocking on naturally occurring factors that might affect the study outcome. So experiments typically, right, have at least 2 groups, a treatment group and a control group. Okay. So experiments typically have at least two groups. Oops. The treatment group and the control or placebo group. There is such a thing as the placebo effect, right? And I think we've all kind of heard about it, or, oh, that's a placebo, blah, blah, blah. Right, and so we kind of know what placebos are, right? It's a fake treatment, right? And the reason we do that is because, well, if you're in this experimental study, right, then, and you think you're getting a treatment, then maybe just thinking that you're getting a treatment, even if you're not, maybe that affects the outcome, right? And that's useful information of its own, right? So just knowing that, hey, if I think that I'm getting this treatment that makes you healthier, for example, right? That's good to know. You can just tell everyone, oh yeah, take these sugar pills and you'll be, well, you wouldn't say sugar pills, right? But, oh yeah, you'll feel so much better. Oh wow, I do feel so much better. Right, so the placebo effect, to try to avoid that, or at least to try to identify that, we say, okay, well, you can do a blind study where the participant is blind to the treatment that they're getting. That's pretty standard, right? Or often what we do is a double-blind study where both the person receiving the treatment and the person giving the treatment does not know which it is, right? Because if you know that someone is getting the treatment, what might happen if you care about the results of the study, right? Even if you're trying not to, right? You might treat that person differently, right? How are you feeling? Pretty good? Yeah, pretty good? Great, right? Things like that. So often what we do is not just a blind study, but a double blind study, right? Where both the participant and the researcher is blind to which group they're in. And so participants are typically blind. I'll put blind in quotes here. Are typically blind to which group they are in. Right. And most often, might not even make sense, but anyways, most often we conduct double-blind studies where the participants as well as, here's where I struggle. I want to say the researcher, but not necessarily the researcher, right? The person who's administering the treatment, right? I'll say that, as well as the person administering the treatment are blind to which group they are in. Right. All of this to eliminate bias, right? And to have a good, reliable sample. Yeah. And with that, we finished chapter 1. like all math teachers. I'm behind already. No, it's okay. We'll get caught up. So for next day, right, for Monday, I'll say, make sure you read 2.1 and 2.2. Okay. We'll talk about 2.1 is about categorical data. How do we usually summarize it in a table? How do we visualize it with a bar graph? That's pretty much all at 2.1. And then 2.2, we talk about numerical data. Again, how do we summarize it? How do we visualize it? That's it. All right. See you guys on Friday, probably. See you then. Close this.